Hey everybody, thanks for tuning in this week to the Supplement Institute. For the first video of the new year, we are handling your request. We asked you guys in a poll what you wanted to see between a vitamin, a mineral, or another workout supplement, and literally 100% of you said a mineral. So let's talk about calcium. Alright folks, before we dive in, a couple of housekeeping things really quick. Number one, I am not a doctor, and I do not play one on the internet. If you are concerned or have questions about possible contraindications with any supplement we talk about, please talk to your primary care physician or your nutritionist, whoever is helping you handle your supplement stack. We are not held responsible. Legalities aside, number two, if you like what you see, please consider hitting that like button, subscribe button, and bell notification so you don't miss any future supplement videos. And number three, if you have a supplement you want to see us do, please leave it in the comments. We see them all and try to respond to them all, and it's highly likely we will get to yours. All right, so we cover four things with every supplement, right? Number one, what is it? Number two, what does it do? Number three, do you need it? And if so, number four, how much should you take? Let's start with number one. What is it? Calcium is a mineral, and it's one you're really familiar with, and you know it's important for bone health, right? Calcium is indeed a building block of bone, much like collagen protein is, but calcium is much more than just a bone health supplement. So for that reason, we're going to try to focus this video on the not as well-known aspects of this mineral. Calcium is actually also important for nerve function, proper contraction and relaxation of muscles, including your heart muscle, blood clotting, blood pressure, and even our immune system health. All right, number two, what does it do? First up, in our vitamin D video, we briefly mentioned how vitamin D was necessary to absorb calcium properly and sufficiently. If you haven't seen that video, the card's at the top. Go ahead and watch that, pause this, or just watch it after. That's pretty important, but since we're talking calcium, let's talk about that absorption process real quick here in the calcium explanation. Now, in order to absorb calcium, there's a few steps involved. In our enterocytes, those are our intestinal lining cells, we find our intestinal lumen. The lumen are these brush-looking things on the enterocyte that actually face the inside of the intestines where food is actually going to be passing through, and it's also where we absorb nutrients like calcium. And in order for our enterocyte to absorb calcium, it needs a calcium transporter. Furthermore, when it's actually in the cytosol, the fluid of the cell, it will then bind to a receptor known as calbindin D. Calcium then uses that and crosses over to the opposite side of the enterocyte where it encounters an ATP-dependent pump that will pump the calcium into the bloodstream. Enter calcitriol or vitamin D, and actually it helps in literally all three of those steps. So vitamin D ends up binding to a receptor or a protein known as vitamin D receptor. I know, I don't come up with this stuff. Which is a transcription factor, which will enter the nucleus of the cell and activate genes. These genes will increase the expression of calcium transporters on the lumen, it will increase the amount of calbindin D in the cytosol, and further, it will increase the activity of that ATP-dependent pump, which pumps calcium into the bloodstream. So it's helping on all fronts. So that's the biochemistry lesson of how calcium is actually getting into us. Let's discuss now what it's actually doing when it's in us by looking at something like muscle contraction. All right, now in order for you to know what's going on fully here, you would feel as if you're sitting through a cell biology lesson, and I'm telling you, I really don't want to do that to you or me. So I'm going to try and simplify this as much as possible, but if after this short-ish explanation, you're still a little confused, or you even still use some big words and you're like, I don't know what any of that stuff was, I highly recommend going and watching a video or two on something known as sliding filament theory. It is this theory that I'm going to try and simplify for us as much as possible, but as a side note, I covered part of this in our choline video, so if you haven't seen that, there's your card, go watch that, pause this, or watch it when we're done. When you want to move a muscle, it requires an electrical signal coming from your brain that travels through a motor neuron that sits atop of a muscle fiber, creating what is known as an action potential. This is created by releasing acetylcholine from the motor neuron into the synaptic cleft. The synaptic cleft is just the space between the motor neuron and that muscle fiber. When this happens, that action potential is created, which causes calcium to be released into the sarcoplasm. The sarcoplasm, think of that as the muscle fiber's cell cytosol. This influx of calcium causes the binding of calcium to a subunit called troponin, which sits on the actin filament and causes a conformational change in the tropomyosin. Now, after a couple more steps, you'll have muscle contraction. But again, I'm trying deliberately not to get too bogged down in the cell biology here. Here's what you need to know. Without calcium, you don't have that conformational change in the tropomyosin, so it can't have a muscle contraction occur. You got it? Stay with me. Similar stimulation occurs in our heart muscle, which is one of the major reasons calcium is so important in heart health. However, you can have too much calcium flowing around in your bloodstream, which would cause inhibition of your sodium channels. And without getting too in the weeds, this would cause improper signaling due to action potentials getting messed up. So you would feel weak, you'd be fatigued, you'd have a lot of confusion. It would be bad news. We don't want too much calcium. And like most things, too little is also just as bad. While too much would lead to muscle weakness and confusion and such, too little would actually lead to the sodium channels being overactive. And this would mean that you would have muscle spasms, numbness, tingling in your mouth and around your fingers and toes, around your lips, and some other more serious side effects, actually, that we won't get into here because, again, I don't pretend to be a doctor and this is not medical advice, okay? Calcium, as mentioned, is also important for our immune health, and this is for a few reasons, which include, but are not at all limited to, activation of our immune system. It allows our white blood cells to get fuel and even allows the white blood cells to multiply. Now, a lot of the biochemical pathway stuff on the immune system portion of calcium is pretty advanced even for a biochemist like myself who does not currently work in immunology, and for general population, it's honestly just not really pertinent. It wouldn't help you at all to know, so we're going to skip that. All right, number 3, do you need it? Well, perhaps. As calcium is mainly found in foods like dairy, yogurt, dark leafy greens, etc. If any of these are lacking in your diet, then yeah, you might not have enough, or maybe your levels just aren't optimal. Also, as we age, our need for calcium, as you may well know, increases. A lot of senior citizens end up taking calcium, so if you're over, say, the age of 50, calcium addition to your supplement stack might be just the thing you need. All right, last thing, how much should you take? Number 4. The current RDA, or recommended dietary allowance, on calcium is between 1 and 1.2 grams, or 1,000 and 1,200 milligrams. And that goes for women ages 18 to 50 and men ages 18 to 70. So that's the amount you would want to have for a complete supplementation, like your current intake is 0. And it's probably not, right? So you'll have to do your own little research here, but think about the foods you eat and try to adjust accordingly, because you really don't need to take it beyond the 1.2 grams per day. Last thing I want to mention is this supplement usually comes in 2 main forms. That would be calcium carbonate and calcium citrate. There are other forms, but those are the 2 main. Calcium carbonate you'll want to take with food, as it requires the stomach acid to break the calcium carbonate bond more fully. Calcium citrate you do not necessarily need to take with food, though it would not hurt. Calcium citrate usually runs a little bit more expensive, but the price is by no means prohibitive in any sense. Like there's almost no price difference. It's just a little more. You'd be fine buying either one. All right, that's it for the calcium video, guys. We appreciate you. Leave a comment for the next Supplement Institute video you want to see. If you have one you want covered, if you have any questions, please leave them in the comments. We see them all. We love you. We appreciate you. We'll see you on the next Supplement Institute video.